Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to the mathematics. In this lecture, we will discuss about the method of solving linear equations. It is important lecture for BSc, ADS, BS IT, BSCS, BS mathematics students. In this lecture, we will discuss about method of solution of linear equations. There are two methods, traditional method and metric method. In this lecture, we will focus only metric method. Metric method has two categories, category A and category B. Category A, row echelon method. In this method, we will get the metric only upper triangle. In category B, reduce row echelon method, if we apply this method in any metric, we get identity metric. It is important note, these two methods are used for three set of equations. Category A is also known as Gauss elimination method, and category B is also known as Gauss-Jordan method. For the both Gauss elimination method and Gauss-Jordan method, for both methods, Gauss elimination and Gauss-Jordan method, we require augmented metric. It is very simple metric. If we have a set of equations, we take the coefficient of the equations and put into in metric form. This metric is known as augmented metric. Let's suppose in left side black block there are three set of equations. We take the coefficients. In first equation, the coefficient of x, that is 2, coefficient of y 1, coefficient of z -1, and 8 written in right side. Similarly, second equation, we take the coefficient -3, coefficient of y -1, coefficient of z 2, and -11 right in the right side. So in third equation, we take the coefficient of x -2, we take coefficient y 1, coefficient of z 2, and -3 right in a right side. So right side, the matrix that is known as a augmented matrix. There are simply says that is coefficients of equations variables. Similarly, if any variable is not available in any equation, so we use in augmented metric 0. So first we discuss the Gauss elimination method. Take the first example. Solve the following equation by Gauss elimination or backward substitution method. We have a set of equation, and this set of equation written in the form of augmented metric. First equation, there is no variable of x, so we use 0. We take the coefficient of y, that is 2. We take the coefficient of z 1 and -8 as it is. In second equation, we take the coefficient of x 1, we take the coefficient of y -2, we take the coefficient of z -3, and 0 as it is. Similarly, in third equation, take the coefficient of x -1, coefficient of y 1, coefficient of z 2, and 3 as it is. This augmented matrix, we will solve this matrix by row echelon method. In row echelon method, first entity is 1 and other two are 0 in any row or any column. Interchange row 1 and row 2 for row echelon purpose. We get the matrix that is 1, -2, -3, 0, 0, 2, 1, -8, -1, 1, 2, 3. For further simplification, we add row 3 with row 1. So after the adding row 3 plus row 1, we get the new matrix that is 1, -2, -3, 0, 0, 2, 1, -8, 0, -1, -1, 3. For more simplification, interchanging row 2 and row 3. New matrix that is 1, -2, -3, 0, 0, -1, -1, 3, 0, 2, 1, -8. For creating upper triangle, we further simplify this matrix. We add row 2 with multiply 2 in row 3. We get a new matrix that is 1, -2, -3, 0, 0, -1, -1, 3, 0, 0, -1, -2. In here, we finally get upper triangle matrix and lower triangle that is 0, 0. So therefore, we write this matrix in equation form, that is first equation that is x -2y -3z is equal to 0. Second equation that is written -y -z is equal to 3. And third equation that is written -z is equal to -2. For more simplify, negative cancel, z is equal to 2. By using equation number 3 in equation number 2, we get the answer of y that is -5. By using equation 3 and 4 in 1, and after the simplifying, we get the answer of x that is -4. So the solution of given equations that are x is equal to -4, y is equal to -5, and z is equal to 2. This arithmetic matrix will solve by using reduce row echelon method. In reduce row echelon method, we create identity matrix in left side of the matrix. For this purpose, we interchanging row 1 and row 2. So we get the matrix 1, -2, -3, 0, 0, 2, 1, -8, -1, 1, 2, 3. For more simplification, row 3 plus row 1, we get metric 1, -2, -3, 0, 0, 2, 1, -8, 0, -1, -1, 3. Interchange row 2 and row 3, we get metric 1, -2, -3, 0, 0, -1, -1, 3, 0, 2, 1, -8. Because we required left side is identity, so we further simplify this augmented metric. For this purpose, row 3 plus 2 multiply row 2, and we get the new metric, that is 1, -2, -3, 0, 0, -1, -1, 3, 0, 0, -1, -2. For more simplification, R1 subtracted 2 multiply R2, we get the new metric, that is 1, 0, -1, -6, 0, -1, -1, 3, 0, 0, -1, -2. For more simplification, R2 subtracted R3 and R1 subtracted R3 commonly, then we get the new metric, that is 1, 0, 0, -4, 0, -1, 0, 5, 0, 0, -1, -2. So finally, our approaches in identity metric in left side of this augmented metric, but the issue is a negative is involved in the diagonal metric, in diagonal identities. So we take the common from row 2 and row 3, or we say that the multiply row 2 and row 3 with -1, and finally we get the answer 1, 0, 0, -4, 0, 1, 0, -5, 0, 0, 1, 2. Therefore, x is equal to -4, y is equal to -5, and z is equal to 2. Thus the solution of given equations are x -4, y -5, and z 2. So the important question, which method is better for solution purpose? Traditional method, or Gauss elimination method, or Gauss-Jordan method? My point of view, Gauss-Jordan method is better for the solution. So what is your answer? Please comment in comment box. Thanks for watching. Please like, subscribe, and press the bell icon.